everyone. So far in this chapter we've learned how to solve a system of equations by graphing. The basic idea of that is you take two linear equations, you draw them both on a graph, and you see where the two lines intersect. The problems with that are sometimes the two lines intersect not at an exact integer value of points, so it may be difficult to see the exact value of the answer. So today we're going to learn another method that is more precise. So this method is called substitution. The idea of this is that we are going to solve one equation for a variable and then plug that equation into the other equation to eliminate a variable. So the first step that we want to do is solve one of the equations for one of the variables. It doesn't matter which variable you choose, just pick the one that's easiest to solve for. Sometimes the step will already be completed for you. Then the next step is to substitute into the other equation. Then you'll have an equation with just one variable. So you have to solve for that variable just using basic algebra 1. And finally, you have to plug the value that you found into one of the equations to solve for the remaining variable. So let's try an example so that you'll be able to see what we're talking about here. So in this example, we have y equals x plus 3 and y equals 2x minus 4. So here step 1 is already completed. Step 1 is to solve one of the equations for a variable. Get any variable alone. Here we actually have two variables alone. In the top equation we have y alone, and we also have y alone in the bottom equation. Now the idea of substitution is we're going to substitute that value back into the other equation. So if y equals x plus 3, then shouldn't this equation be equivalent to x plus 3 equals 2x minus 4? Here, I've completed the second step where I've plugged one equation into the other. So I have one now basic equation with only one variable, and I can use basic algebra 1 to get that variable by itself and figure out what x equals. So the first thing that I want to do is get my variables together. So I'm going to have 3 equals x minus 4. It doesn't matter which side you bring x to, I just brought it to the right so that my x coefficient would be positive. Then I'm going to add the 4 to both sides to get the x alone, and I solve that x equals 7. Now I know one of the values where the two lines intersect. I still have to find the other. The way I find the other is I take the value that I found and I plug it into either of the beginning equations. It doesn't matter which one you choose. Just pick the one that you think is the easiest. The top one looks a little bit easier, so I'm going to take 7 and plug it back in for x in the top equation. So I learned that y equals 10. So this point is the solution point. I get the point 7, 10, which is where the two lines intersect. If you want to verify this with the graphing method, you would find that these two lines intersect at the point 7, 10. Now let's try another example. In this example, only one of the equations has one of the variables alone. You still don't have to do step 1 because there is one variable that is alone. So now step 2 is to take that equation and plug it into the other one. So if x equals y plus 4, now I'm going to take this quantity and plug it in for x. Replace the x with y plus 4. So I get 2. Now I'm going to plug y plus 4 in, plus 3y equals 43. I know that this equation looks like it's more complicated. However, this is desirable because there's only one variable instead of 2 like there were in the previous equations. So now it's just a matter of simplifying and solving using algebra 1. So the first thing that I need to do is distribute the 2 through the parentheses. So I get 2y plus 8 plus 3y equals 43. Now I'm just going to combine like terms, and I'm going to get 5y plus 8 equals 43. Now to isolate the y, or to get the y alone, I'm going to subtract 8 from both sides. I then get 5y equals 35. Divide by 5, and I get y equals 7. So now I know that my y coordinate of that point of intersection is 7. I still need to go back and find the x. So here, this completes step 3, where I've solved for one of the variables. Now we need to use that answer to solve for the remaining variable, or to figure out what x is. So it doesn't matter which equation I use, I always pick the one that's easiest. So I'm going to take the y equals 7 and plug it back into the top equation. So x equals 7 plus 4, 11. So now I know that the point of intersection is 11, 7. There is a way to check your answer, and that way is to plug this point back into both equations. If it's a solution, it should make both equations true. So let's try that now. I have 11 equals 7 plus 4. All I did was take this x value and this y value and plug it into this equation. That is true, so the first equation verifies our solution. Now let's try to do the same thing with the second equation. So 2 times 11, because that's the x value, plus 3 times 7, because that's the y value, should equal 43. So let's make sure that that actually works. This is 22, this is 21, and that does equal 43, so it worked. If you made a mistake in finding this point, then when you go back and check your answer, it won't come out true. You'll get some invalid statement, such as 11 equals 13. If that happens, then you know that you made a mistake somewhere in these steps, and you should go back and check your work. So let's try this example now. So this is an example where we do need to do step 1, where there is not a variable that's already alone. It does not matter which variable you pick to get alone, all of them are mathematically correct, but I always pick the one that's easiest. So there's a few that are easy here. The x would be kind of easy to solve for, and so would this y. I'm going to solve for this, the top x. In order to get the top x alone, I'm going to add y to both sides. That transforms the top equation into x equals y minus 4. The reason that I wanted to do that is because I have to get a variable alone in order to substitute it into the other equation. So now that I have an equation where a variable is alone, I can complete step 2, where I'm going to take this equation and plug it into the other one. So now with this equation, it's going to become 3, and instead of x, I know that x equals y minus 4, so I'm going to plug that in for the x value. Then I'm going to continue writing this equation. Plus y equals 8. Now, just as in the other equation, I do need to distribute before I do anything else. So distributing this 3 through the parentheses results in 3y minus 12 plus y equals 8. The next thing I need to do is just combine like terms. So here I have 4y minus 12 equals 8. In order to isolate the y and get it alone, I'm going to add the 12 to both sides. Then I get 4y equals 20. I divide by 5. Oops, I'm working ahead of myself. I should divide by 4. 5 is going to be the answer. Then I get that y equals 5. So this completes step 3, where I've gotten one of the variables. So now I know the y coordinate of that answer, that intersection point, is 5. I still need to go back and find the x. You can use any of the 3 equations that we've been dealing with in this problem. We started with 2, but then we manipulated the top equation to get another equation. If we take this y equals 5, then I get x equals 5 minus 4, which is 1. So just to remind you that this is the answer because this is where the two lines intersect. If I graphed these two lines on a coordinate plane, I would get that the two lines intersected at the point 1, 5. And that's our lesson for today. Thank you for listening.